So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on mass defect. So let's discuss the worksheet. So here is the question that the first question is mass energy equivalences. So this is E is equals to mc square. Next is we are being given a graph between E and M. So the graph will be a straight line, and if we look for the slope will be tan theta, which will be E by M or C square. Next is what is energy corresponding to 1 kg mass. So E is equals to mc square. M is 1 here, C is 3 into 10 is to power 8. So on solving this we get 9 into 10 is to power 16 joule. Next is energy corresponding to 1 gram mass. So 1 gram means 10 is to power minus 3 kg, and after solving this we get 9 into 10 is to power 13 joule. Next is energy corresponding to 1 milligram. So 1 milligram means 10 is to power minus 6 kg, and we get 9 into 10 is to power 10 joule. Next is energy corresponding to 1 microgram. So we have 9 into 10 is to power 7 joule. Next is energy corresponding to 1 AMU. So E is mc square, which is 931.5 mega electron volt. Next is energy corresponding to electron. It is 0.51 mega electron volt. Next is energy corresponding to proton. So proton has a mass of 1.67 into 10 is to power minus 27 kg. So if we convert that into mega electron volt, it's about 938.27 mega electron volt. Then for neutron, it is 939.565 mega electron volt. Next is what is mass defect for ZXA. So mass defect is mass of nucleons minus mass of nucleus. So there are Z protons, A minus Z neutrons, and let the mass of nucleus is M. So the difference will be the mass defect. Next is binding energy. So binding energy is delta M into C square. Next is binding energy per nucleon. So that will be delta E by A, which is delta MC square by A. Next is we are being given the graph of binding energy per nucleus versus A. So the graph is like this, and it has got a maxima for iron 56 and at a maximum value about 8.8 mega electron volt. Then is binding energy per nucleon is maximum for, so it is maximum for 26 iron 56. Next is variation of binding energy per nucleon. It's just like that as shown here. Next is mass defect for 3Li7. So it is 0.042 AMU. Next is binding energy for 3Li7. It is 39.2 mega electron volt. Next is binding energy per nucleon for 3Li7. It is 5.6 mega electron volt. Next is we are being given a question: A plus B gives C plus D plus let's say the heat released is Q. So the first question is mass defect. So mass defect is mass of reactant minus mass of product, which I name as delta M. Then is binding energy. It is delta M into C square. Then we have to find Q. So Q is delta M into C square. Next is kinetic energy of products. We assume that no heat loss, so it is Q. Entire energy gets liberated as heat, as Q value of the reaction. Next is momentum of C. So momentum can be given by this expression. It's based on conservation of energy. Next is speed of C. So from here speed of C is given by use P is equals to m1 into v1. So from there we can calculate v1 as this. Next is speed of D. So using m2 v2 is momentum. So from here we get the speed of D shown by this expression. Next is kinetic energy of C. So it is given by qmd upon mc plus mb. So you have seen that these worksheets are designed to make sure that your learning patterns are optimized as per the exams. So these are the optimal worksheets to make sure that your preparation is aligned with the psychological patterns of JEE NEET. As you might be knowing that every competitive exam is based on certain neurological and psychological patterns, and you can crack those exams only if your mind brain system is optimized for those psychological patterns. So these worksheets are just a small effort to make sure that you check your mind brain algorithm, your mind brain system when you solve a particular question, and try to align your thinking process with the line of action of the patterns asked in the competitive exams. Only then you can crack that out. Thank you and have a nice day.